Assalamu alaikum class. Last time we have studied about nomenclature of alkane, and in this video lecture we will discuss about alkane and different methods to prepare alkane. First of all, what are alkanes? Alkanes are hydrocarbons. These are hydrocarbons in which one carbon makes single bond with another carbon atom, in which carbon atom makes single bond with other carbon atom and we can say all carbons are sp3 hybrid. All carbons are sp3 hybrid. sp3 hybrid, and their general formula is CnH2n plus 2. CnH2n plus 2. Alkanes are also known as paraffins. These are also known as paraffin. Why alkanes are known as a paraffin? Because they are least reactive, so we also name them as a paraffin. And the simplest example is methane. Simplest example is methane, CH4, and methane is also known as natural gas. Methane. Now, general methods of preparation. First of all, we can prepare alkane from alkenes or any unsaturated bond, carbon, double bond carbon. So, naming the first method as hydrogenation. Hydrogenation of alkene or alkyne. We can prepare alkane from alkenes and alkynes by hydrogenation. Next method is from hydrogenolysis. Hydrogenolysis of alkyl halide, or we can also form alkane by the removal of halogen atom by reacting alkyl halide with zinc. Reaction of Zn in the presence of any acid like HCl, in the presence of HCl with alkyl halide. This reaction also yields alkane. And fourth method is decarboxylation of monocarboxylic acid. Decarboxylation of monocarboxylic acid. carbon dioxide from monocarboxylic acid in the presence of sodium hydroxide, and catalyst is calcium oxide. And when we heat these three things, it forms alkane by the removal of carbon dioxide. Next method is, fifth method is Kolbe's electrolytic method. Kolbe's electrolytic method. It is very famous method for the preparation of hydrocarbons like alkane, alkene and alkyne. In this method we use salt of any carboxylic acid. If we use salt of monocarboxylic acid, then it will form alkane, and if we use salt of dicarboxylic acid, then it can form alkene or alkyne. Next method is by reduction of aldehyde or ketone. We can also form alkane by reduction of aldehydes and ketone. And last method is by Grignard reagent. By Grignard reagents. Students, now moving towards the method that we mostly use for the preparation of alkane. First method is hydrogenation. Hydrogenation. What is hydrogenation? Simply we can say that it is the addition of hydrogen. It is the addition of hydrogen. Addition of hydrogen and this addition is in the presence of any catalyst, in the presence of catalyst, and we use mostly nickel, palladium or cadmium as a catalyst. The main catalyst is nickel. Why we use nickel? Because nickel is a cheaper catalyst, and we can also use palladium or cadmium. Palladium and cadmium are expensive catalysts, but for the effective hydrogenation we can also use nickel as a catalyst, but it needs higher temperature for the reaction. In this case we convert alkene or alkyne into alkane. First, I am taking alkyne, carbon, triple bond carbon, and here will be any group. I am putting just alkyl group. You can use hydrogen, CH3, CH2, CH3, depend upon your own choice. I am hydrogenating it in the presence of catalyst like nickel, and the temperature will be 200 to 300 degrees Celsius. When this reaction ends, it forms alkene. Carbon double bond carbon, alkyl group. Here is hydrogen and here will also be hydrogen. Up to this step we can name it as a partial hydrogenation. And when we add some more hydrogen to this reactant, then this product will convert into alkane. R group, carbon, hydrogen, hydrogen, single bond carbon, hydrogen, hydrogen, and here will also be alkyl group. It is a complete hydrogenation of alkyne, or we can say that we are doing hydrogenation of alkene, and when we perform hydrogenation to any alkene, it will convert into alkane. We can write here as a positive plus sign. we are adding one hydrogen molecule, one mole of hydrogen to other alkene. Next method is decarboxylation of monocarboxylic acid. Monocarboxylic acid. What the term is telling us? Decarboxylation. Decarboxylation is that we are removing carbon dioxide. It means that we are removing carbon dioxide from the reactant. D means removal. It means removal. Carboxylation, CO2, removal of CO2. And in this we use sodium hydroxide, NaOH. It is used as a reactant or reagent. Calcium oxide CaO is used as catalyst, and when we add these three things, just we have to heat the mixture and it will form any alkane. For example, if we have monocarboxylic acid or C double bond O, OH, and here is NaOH. In the presence of catalyst CaO, and by heating it will form any alkane or H, and side product will be NaHCO3. NaHCO3. Sodium bicarbonate. It will form NaHCO3, and it will form RH. RH is any alkane. When we remove one hydrogen from alkyl group, one hydrogen from alkane, it forms alkyl group, and when we add any hydrogen to any alkyl group, it forms alkane. Next method is by Grignard reagent. By Grignard reagent. By Grignard reagent, we know that Grignard reagent is R, Mg, and X. We can form many things from Grignard reagent, and when we react Grignard reagent with water molecule, it forms alkane. When we react Grignard reagent with water molecule, it forms alkane. Or MgX plus HOH. It is partial positive, partial negative, and it is partial negative, partial positive. We know that the bond between alkyl group and magnesium is reactive, and it will pick hydrogen atom. It will pick hydrogen atom, and this hydroxyl will attach with this magnesium atom, and the resultant product will be alkane or H. It's alkane and MgX and OH. I hope that you have completely understood these three mechanisms. Now moving towards the most important preparation method, that's cold electrolytic method. Cold electrolytic method. I am going to erase this portion. kolbe's electrolytic method. In this, we take a cell or beaker like this, and we add our reactants in this solution. The solvent is H2O, and we add carboxylic acid as a reactant, and after that we also add 2 electrodes in the solution, and we connect these 2 electrodes with batteries. First become anode and second become cathode. What happens in that mixture? If we have monocarboxylic acid or single bond carbon, double bond oxygen, OH, and this reaction is being occurred in water solvent. When we add carboxylic acid to water, it ionizes itself and forms 2 types of ions. First is R carbon double bond oxygen negative, and second ion is H positive, negative and H positive. And when we connect those 2 electrodes with electrical source, then we can say one electrode becomes cathode and second becomes anode. If we write it as a cathode and its anode, cathode is negatively charged and anode is positively charged. And here are negative ions and positive ions. Now these negative ions will move toward anode and these positive ions will move toward cathode. Positive ions will move toward cathode. And if we use sodium salt of carboxylic acid, then this hydrogen will be replaced with sodium Na, positive and negative, and here will be formation of sodium ion Na positive. Then the positive ion will be sodium, and if we use just carboxylic acid, then there will be the formation of hydrogen gas, and if we use sodium salt of carboxylic acid, then there will be the formation of sodium hydroxide. And in this case, what will happen? This negative part of carboxylic acid will move toward anode. Then we can say the reactions occurring at anode, so heading it as at anode. When this anion reaches on anode or carbon double bond oxygen O negative, it loses 1 electron and converts into radical or carbon double bond oxygen and O radical. We know that the radicals is more reactive species. When it forms in a reaction, it will react rapidly. And in this case, here is a bond. 1 electron will move in between carbon and oxygen, and this electron will move toward here. Now this electron comes over here. One molecule converts, one part of the radical converts into carbon dioxide, and here will be the formation of alkyl radical. One carbon dioxide will be released from the mixture, and here will be alkyl radical. If we use 2 mole of sodium salt of carboxylic acid, then there will be the formation of 2 alkyl radicals, and when these alkyl radicals come in contact with each other, 1 electron of this alkyl radical will come over here and its electron will come over here. Here will be one bond between these 2 alkyl groups, and these 2 will convert R single bond R, and it is alkane. Now moving toward the second part, that's occurring on cathode. Second reaction at cathode. Cathode is actually electrode having negative charge. When water molecules come in contact with cathode, water molecule will gain 2 electrons. It will gain 2 electrons and converts into hydrogen gas and hydroxyl group. This hydroxyl group will combine with sodium and convert into sodium hydroxide. Converts into sodium. Just about alkane. First of all, what is alkyl group? What is alkyl group? If we have any alkane, and we remove one hydrogen from alkane, one hydrogen from alkane, then it forms alkyl group. It forms alkyl group. For example, we have methane CH4, and if we remove one hydrogen from CH4, it becomes CH3. CH3, and it is methane. It is methane, and when we remove one hydrogen from alkane, it forms alkyl group, and here it is methyl. Methyl. Just keep in mind, when we form any alkyl group, we just replace A and E of alkane with YL. Another example, if we have ethane, CH3, single bond CH3, it's ethane, and I am going to remove one hydrogen from this CH3 group. Now it forms CH3, CH2. It's ethyl. It's ethyl. Now look it again that A and E is being replaced by YL. It is the easiest name that in which we just replace A and E of alkane with YL. And how alkyl group is formed? When we when we remove one hydrogen from alkane, it forms alkyl group. And mostly we show alkyl group with a capital R. Capital R in hydrocarbons just represent the alkyl group. And it may be methyl, ethyl, propyl, butyl, and so on. Now moving toward the nomenclature of alkane. Nomenclature of alkane. The first rule of the nomenclature of alkane is the selection of longest chain. First rule is to select the longest chain in hydrocarbon. For example, we have a molecule CH3, CH2, CH, CH2, and CH3, and here is CH3. In this case, there are two main chains. I am going to mark both of them. First chain is here and second chain is here. Now count the number of carbons. Here are just 4 carbon atoms. 4 carbon atoms. And in this chain, we are looking that here are 5 carbon atoms. So according to first rule, we will prefer this chain. It does not matter that how it is turned, how it is going straight. Just we have to keep in mind that there should be large number of carbon atoms. So in this case, this will be parent chain of hydrocarbon. Another example, CH3, CH2, CH, CH3, and here is CH2, and here is CH3. Now look at this molecule. If I mark the longest chain, there is one possibility, and there is another possibility that here are the maximum number of carbon atoms. In this case, you can see there are 4 carbons that are linking by catenation, and in this case 5 carbons are linking with each other, and we are ignoring that how this chain is straight or it is bronze. In this case, that here are large number of carbon atoms, so we will again prefer this chain. First chain will not be selected as a parent chain, second chain will be selected as a parent chain because it has greater number of carbon atoms. Next, assign the number to carbon atoms. Second rule is assign the numbers to carbon atoms from where substituents should get minimum. Substituent should get minimum. Now looking the above examples, what are substituents? Actually, substituents are the branches or those groups which are attached with the parent chains. In this case, this CH3 is a substituent, and in this case, this CH3 is a substituent. Now we have to give number to the parent chain of hydrocarbon and keep in mind that we have to give lowest possible number to any alkyl group or substituent. In this case, if I give numbers from this side 1, 2, 3, 4 and 5, or from this side 1, 2, 3, 4, 5. Now we are looking that the substituent is attached on third carbon in both cases. So here is a possibility of numbering from both sides. Another example, CH3, CH2, CH3, and here is CH3. Now, in this example, it is the longest chain. And if we give number from this carbon, first, second, third, and fourth, in this case, this substituent is getting number 3. And if we give numbers from this carbon, first, second, third, and fourth, from this side, this CH3 is getting number 2. So, from this side, the numbering will be preferred because substituent is getting minimum number. The next rule is assign the position to a substituent. Assign the position to a substituent and give name to substituent, and at the end you have to name the parent chain. Assign position to a substituent and name it, then name the parent chain. Now, in these cases, if I give name to this hydrocarbon, here numbering can be possible from both sides because we are looking that the substituent is on carbon 3. So, how we name it? First of all, assign the position to substituent. It is present on carbon 3. Write 3. What is the name of that substituent? It's methyl. 3 methyl. And how many carbons are present in parent chain? There are 5 carbons in parent chain. So its name will be 3-methyl pentane. 3-methyl pentane. It is also 3-methyl pentane. In this case, the numbering possible from this side. It's 1, 2, 3 and 4. C3 is present on carbon 2. Now first of all assign the position to substituent. Then name that substituent. It's methyl group. 2-methyl. And at the end name the parent chain. The parent chain contains 4 carbon atoms, so it is butane. 2-methyl butane. If we have multiple substituents in parent chain, then we will use, if those substituents are similar, then we will use di, tri, tetra, penta and so on. And if we have different substituents starting from different name, then we will keep their order by alphabetically and give name to that molecule. We have some examples of such type of molecules. Now I am going to erase the first tool. In case of the fourth rule about similar substituents, in case of similar substituents, we use di for 2, tri for 3, tetra for 4 and so on. For example, we have a molecule CH3, CH, CH3, CH, CH3, CH3. In this again we have to select the longest chain. It is the longest chain. And assign number to parent chain from those side, from that side, from where substituent has minimum number. In this case, if I give number from this side, the substituent is on 2 position. And from this side, it is also present at a second carbon. So, giving numbers from this side. Now, mention both positions of alkyl groups or substituents. It is present on second carbon, so 2 will be mentioned here. And second substituent is present on third carbon, then we will write 3. And these are 2 actually substituents and similar substituents, then we will write di. Di is used for 2. It is 2,3 di and methyl 2,3 di methyl, and parent chain contains 4 carbons, so it is 2,3 dimethyl butane. I hope that you have understood it. Another example, CH3, CH3, CH3 and CH3. In this case, we have to select the longest chain again. Here is the longest chain, and first, second and third. We are looking that at second carbon there are 2 similar substituents. Then we will mention their position that 2, 2. You can write just 2 because it's propane. 2,2 dimethyl, 2,2 dimethyl propane. I hope that it is very clear to you. Now moving toward next rule. In case of different substituents, in case of different substituents, if we have different substituents, then we will arrange them according to alphabet. We will keep their order in alphabetically. So, for example, it is CH3, CH2, CH2, CH3, CH2, CH, CH3, and here is CH3. Now first of all select the longest chain. Here is the longest chain. You can also select this longest chain. If I have chosen this longest chain, then second rule is to give the number to a carbon. Now if I number from this side, the carbon, third carbon will have the substituent, and from this side second carbon has the substituent. Then we will prefer from those side, from that side, from where the substituent get minimum number. So carbon 1, carbon 2, carbon 3, carbon 4, 5 and 6. This numbering will be accurate. And it's methyl, and it is ethyl group. Now according to alphabetically order, E comes first and M is a letter. So we will first write ethyl group. First of all, write its position 4. What is its name? It's ethyl group, 4-ethyl. Then write the position of second substituents, that methyl, 2-methyl. And at the end, write the name of that parent chain. This parent chain contains 6 carbons, so it's hexane. It's hexane. If we have different substituents, then we have to maintain their order according to alphabetically. And in this case, we also can use di, tri, and tetra for similar substituents. Next, I am going to discuss different more examples of nomenclature. Students, now moving toward solution of some examples of alkane. In this case, the first molecule has almost 4 carbon. Now we have to apply all the rules step by step. First case, we have to select the longest chain in this molecule. In this molecule, it is the longest chain. And from both sides, we are looking that second carbon has a substituent, so we can give number from this side, 3. It is present on second carbon, so mention the position of that carbon, it's second. And what is this? It's methyl. How many carbon are there in parent chain? There are 3 carbons, so it's methyl propane. Methyl propane. In second molecule, first of all, select the longest chain. If I go straight, there are 5 carbon atoms, and if I select this chain, here also will be 5 carbon. It's your choice which chain you want to select. I am going to select the straight chain. If I mark the number from this side, third carbon has substituent, and from this side there is also third carbon. So from this side, first, second, third, fourth and fifth. Third carbon has substituent and it's ethyl. So first of all, mention the position of substituents. It's present on carbon 3, and which substituent is that? It's ethyl, 3-ethyl. And how many carbon atoms are there? There are 5 carbon atoms, so it's 3-ethyl pentane. 3-ethyl pentane. Now moving toward next molecule. Again we have to select the longest chain. In this case, it is the prominent chain that is the longest one. And now second rule is to give the smallest number to a substituent, and from this side substituent is present on carbon 3, and from this side substituent is present on carbon 2. So we will prefer this side, first, second, 3, third, fourth, fifth, sixth and seventh. Now there are 2 types of substituents. It's methyl and it's methyl, and it's ethyl. According to alphabetically, we have to write first ethyl group. So mention its position. It's present on carbon 4, ethyl. Then there are 2 similar substituents, and those are methyl groups. So first of all, mention the position of first methyl group. It's second. And second methyl group is present on carbon 5, 2, 5. 2 methyl groups are here, so 2, 5, dimethyl. And parent chain has 7 carbons, so it's heptane. It is heptane. have to follow all the rules. We have to arrange the different substituents on the basis of their alphabetically order, and we also have to use di, tri or tetra, something else. In case of fourth example, again we have to select the longest chain, and here is the prominent longest chain. From this side substituent is present on carbon 2, and from this side substituent is also present from carbon 2. Here is the problem. Now we have to assign the number from that side where number of substituents are greater. So this side has greater number of substituents and this side has lesser number of substituents getting minimum number. So numbering will be from this side, first, second, third, fourth and fifth. And all substituents are methyl group. So mention the positions of all methyl groups. Two methyl groups are present on carbon 2. Mention both as a 2, 2. And one methyl group is present on carbon 3, 2, 2, 3. And fourth methyl group is present on carbon 4, 2, 2, 3, 4. How many methyl groups are there? There are 4 methyl groups, so it will be 2, 2, 3, 4. Tetramethyl. 2, 2, 3, 4. Tetramethyl. And how many carbons are there in parent chain? There are 5 carbons, so it's pentane. It's pentane. Now moving to our next example. In this case, first of all, you have to write it in structural formula. We can write it as CH3 bond CH3. Here is CH3, CH2, CH3, CH3 and CH3. This thrice means that 3 CH3 groups are attached with this carbon atom. So we can write it in open form. Now we have to select the longest chain. It is the longest chain present in this hydrocarbon. And numbering from this side, first, second, third, fourth, fifth. Now assign the position to substituent, and all substituents are methyl group. On carbon 2 there are 2 methyl groups, so writing 2 and 2. On carbon 4 there are more 2 methyl groups, 4 and 4. Actually there are total 4 methyl groups, so we will write tetramethyl. Tetramethyl. And the parent chain has 5 carbon atoms, so it's tetramethyl pentane. In this case, again we have to write its open structure. We have to write its structural formula. One carbon is attached with one hydrogen atom, and there are 3 benzene rings. First benzene ring, second benzene ring, and third benzene ring. I hope that it's visible to all of you. Now we have to select the longest chain. Actually these 3 rings are acting here as a substituent, and our hydrocarbon has main 1 carbon, and that acting as a parent chain. So it's just methane. It is just methane. And this methane is substituted with 3 benzene rings, so we can name it as triphenyl methane. Now moving to 7th example. In this again we have to select the longest chain, and it is the longest chain in this hydrocarbon. Next we have to assign number to carbon present in parent chain from that side where substituent get minimum number, and this is the side from where this substituent get minimum number. Second, third, fourth and fifth. Now write the positions of substituent. We are looking that first substituent is present on carbon 2 and second is present on carbon 3. So it will be as 2, 3, 2, 3 dimethyl 2,3 dimethyl, and parent chain contains 5 number of carbons, so it's pentane. It's pentane. In this case, this 3 is showing that CH2 is actually in the form of series. 3 CH2 groups are here in the form of series. We have to write it in open form. It will be CH3, CH2, 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 and CH3. And we know that the molecule having 5 carbons, then it will be pentane. There is no substitution of any group, so it is the parent chain, and there is no any issue of numbering of carbon atom. Here again we have to select the longest chain, and it's 3 carbon chain. Second carbon has 2 substituents, 2C3 substituent, so we have to write their position 2, 2, and both substituents are methyl, so 2 dimethyl, 2 dimethyl propane. I hope that you have learned the whole nomenclature, IUPAC nomenclature, with efficiency and effectively. If you have any question regarding nomenclature, you may ask in comment section. And you can also you can share my videos in description links. Thank you, and don't forget to subscribe my channel. Allah Hafiz.